All right, welcome back. So in this video, what I'm going to be talking about is how do we deal with the fact when we left off in this code here, we were looking at the timer, and what we want to do is measure the clock period, and this code does that. It measures the clock period, but one of the things that is problematic with this code is that these interrupts, these timer interrupts are happening all the time. And that turns out to be quite problematic, especially if you look at how this sensor, its dynamic range, you're talking about potentially hundreds of kilohertz, hundreds of thousands of interrupts per second, which are, for the most part, unnecessary, right? We don't need those. What we really want to do is we're going to sample this signal, so we're only going to look at it. We only need two edges, but we only need the two edges right after we decide we want to compute the period. So I'm going to revise this code to get us to the point where we can actually just get those two edges, and then we're going to kick off the interrupt. So let's look at this code. Again, this is where we're starting from last time. I'm going to focus at least at first here in this code around this capture callback, because what I want to do is instead of running this all the time, what I'm going to do is when I've captured my second edge, I'm going to turn off the interrupts. All right, so let's come in here and let's assume that we've got a function that when we run it, it turns on the capture interrupt, and then we're going to capture a couple of edges, and then we're going to turn off the interrupt. So let's see how that plays out here. All right, so I'm going to create a new variable in here. I'm going to call it state. And I'm going to give it the value first edge. Up here, I'm going to create an enum. So if you haven't used an enum before, all an enum is basically, it gives these values a numerical value, 0, 1, but it lets me talk about them with a name. And for building a little state machine, which is what I'm going to build here, that turns out to be pretty useful. The other thing I'm going to do here is I'm going to come down here into this code here, and I'm going to copy this. I'll put it down below here. Just kind of get it out of the way, and I'm gonna get rid of it for now. So we've got this code down here at the bottom. We're gonna need it here in a minute, but for now, let's kind of get it out of the way. Okay, so I'm using a switch statement. I could use an if statement here, but I'm gonna use a switch, and because the switch makes it a lot, I think, easier to think about state machines. So I'm gonna say switch state. Case, and then I'm going to have first edge, break, and then I'll have, oops, forgot my semicolon, case, second edge, break, then I'm going to have my default, and I'm going to I'll fill in default here in just a minute. All right, so I've got this first edge. What do I want to do on the first edge? Well, I'm going to have a flag that I'm going to set. And one of the problems we've got is it's unknown, from the caller, the function is trying to gather these edges. It's unknown when this thing's going to be done, right? For instance, it may be done very quickly because of the frequency's high. It's going to be done relatively quickly. Or it may take, seconds or even minutes if it's dark. So I'm going to have a flag here that I set, the calling function sets, and then it's going to clear it in here to let us know we're done. And again, this is all happening in an interrupt. So I'm going to say if TSL237 flag, so if it's set, then I want to do stuff in here. And so what stuff is that? Well, I want to go ahead and grab the last. So I'm going to grab this code down here where I grab the value. So I'm going to go ahead and grab it here. Equals that. Then I'm going to set the state equal to the second edge. Now make sure you don't forget these breaks. If you forget the break, then it'll go ahead and fall through and actually run the second state here. In this case, what I want to do is once I hit this, I get this first edge, only on the next running of this handler would I want to process the second edge. All right, in the second edge code, I'm going to go ahead and grab this code down here that I grabbed. I'm basically going to follow the same code here, and I'll put it basically right in. A bit spoiled from Emacs when it handles the alignment of things like this. We don't need this here. Okay, so at this point, we will have computed our period, right? So that's the same variable that we had before. I want to go ahead and clear the flag that we were actually polling on. Or we will be polling on it. And I'm also going to, the thing I want to do now is turn off that input capture interrupt. So I'm going to come down here where I had my timer set up. And if you remember, I did this timer IC start. Well, what I'm going to do here is I'm going to grab that code. And I'm going to put it down here at the end. And I'm going to change this function here to stop. So I can go and confirm that that's indeed the name. So if you just look at the declaration of start and stop, you can see that. With these headers, you can figure out what the name of the actual opposite function is. All right. So the last thing I want to do here is I want to set the state back to first edge. All right. And then I think in the default, if the states somehow get to be some value that is unexpected here, I just want state to equal first edge. And then, let's see, that should be the end of the, one of these for the, all right, so there we go. So we've got our interrupt handler. So now with this little state machine, when it gets that second edge, it's going to kick off the interrupts. And so we'll only get two edges. So now let's write the function that will, I got to get rid of this extra. Let's write the function that will stimulate this to actually start, right? So we need to do things like set this flag, which is going to be a global variable. And then we need to actually call the thing that starts the interrupt. So I'm going to create a function called read TSL237 frequency. And in here, what I'm going to do is I'm going to create a float that's called sensor period. And I will TSL237 flag. I'm going to set that flag. Then I will go ahead and call this. And in fact, I'm going to cut it from right here. I'm going to go ahead and grab this code right here. and I will copy it, and then I'll turn it off. So I'm only going to turn on these interrupts when I call this function. So I'll turn it on right here. So now the interrupt should start. And so now what I'm going to do is I'm going to wait for this flag to clear. So I'll just wait. I'll poll, waiting for that function to clear. And then once it has done its thing, the value of period has now been changed. I'm going to grab this function right here. And I'm going to say sensor period equals this thing here. And finally, I'm going to return 1 over sensor period, which will be the frequency. All right. So now I've got a situation where I only turn on the interrupt when I want to do it. This little state machine decides, okay, I've got both edges. I've got a new period has been computed. I stop the interrupts. I set the flag back to 0, and voila, the whole thing finishes, and I've got the value that I need. All right. So I need to go and create a couple variables here. I need to come up here to volatile unit 32T. I'm going to call this TSL237 flag. Set it to 0 to start with. All right, now down in our main code here, I'm going to take that out, and I'm just going to call my function here, the read TSL237 frequency. So now we should be able to just call this. To accomplish what we were trying to accomplish last time. We were basically, now, this will be immune to, you won't need to tape your sensor anymore because this will be immune to high frequency. It just won't care, right? Because you're only going to run it for 2 clocks. And in fact, it'll just complete faster. Effectively, because we're waiting on that flag, we're polling in this particular instance. So even though we're using interrupts, when we call it from the main loop here, we are polling to see if we've got it. So, okay. So let's go ahead and stop this. I think I was doing this from inside of the... All right. So let's go ahead and fire the bug up. All right. So here we are. Got our code running. Of course, the interrupt is not going to happen here until we run the function at least once here. So now when I run it, I'm getting a value of 347, 348, and that's about right. If I look over at my scope, it's in that sort of neighborhood. As I move around in the room, it kind of changes. But now we've encapsulated this, and so regardless of how fast that frequency is running, it's going to allow us to make a measurement and then be done. Now, you might be saying, well, is there a better way to do it than this? And you know, the next step beyond this would be to use something like DMA. Tell DMA to take to go and grab us 2 values from the timer. And so the DMA engine will run for 2 cycles, and then it will give us our value, and we can just compute it that way. And that would avoid the polling altogether. And so that's probably the next step, but this gives you a way to get this problem solved without bringing DMA in. As we bring in more and more complexity, like bringing in DMA, it just makes the problem maybe a little bit harder to visualize what's going on. So I was hoping that having the idea that you can build a state machine like this would make it easier to conceptualize what's going on. All right, so that's it for this video. Again, this shows you kind of how to break this apart and come up with a state machine to deal with the edges here. Again, like I said, the next step beyond this would be to bring in the DMA engine to do this for us. We don't have to deal with the fact that we've got the potential to get deadlocked here if this flag never gets cleared. And so we could do this with DMA to avoid that. I think for now, I think this is probably where we'll stop on this, just to kind of get your feet wet with this. And then down the road, we'll talk about DMA in another context. All right, that's it for this video.